Hello, welcome back. Today we're doing the last new section in chapter 11, and this is more work on graphing quadratic functions. So the big difference in this is that unlike the 11.5 problems, the initial setup will not be done for us. So this is kind of combining section 11.1 with section 11.5. And there's just a couple other questions that they'll ask us in this. So some key features of a quadratic function. We have that distinct U shape, and it could open up, it could open down for a quadratic. This point where the turn happens is what's referred to as the vertex. That's one of the things they could ask us for, is where the vertex is. It will be an ordered pair. Which direction it opens, up or down. All intercepts, those are also ordered pairs. And what's called either the axis of symmetry, sometimes also called the line of symmetry. This is always an equation. So the vertex, really we just see what happens as far as shifting and where 0, 0 gets shifted to. The direction it opens, that's going to depend on our leading coefficient. Intercepts are the same as they've always been. If it's an x-intercept, y has to be 0, and vice versa. And the axis of symmetry or line of symmetry, notice that if you hold sort of a mirror up to the middle of this, you have the same image on both sides, whether it opens up or down. The place where you would put that dotted line is the axis of symmetry, also called the line of symmetry. Notice that it goes right through the vertex, so these two are going to be related to one another. Okay, so our first problem that we get to play with, f of x is going to be 2x squared plus 2x plus 5. So it's going to ask us for all of this and sketch the graph. So to start with, we're not in the nice, easy to read format that we were last time. All the ones in 11.5 had the basic format. Y is a times x minus some constant, it's quantity squared plus k. But we do know how to complete the square. That was our 11.1 work. So we'll temporarily move to y equals notation, and we will sort of move this 5 over. That's more a cosmetic change at the moment. It'll have more practical purpose in a minute. Remember, when you complete the square, you want your leading coefficient to be a 1. If it's not, you do have to fix that. Now we have a couple options. We can either divide everything through by 2, or we can just factor the 2 from these two terms. I'm going to choose sort of the simpler one of just factoring the 2 from those two terms. Notice I've left a little space here as well. So now that I have a 1 as the implied coefficient in front of the square term, at least within the parentheses, now we can complete the square using the same method from 11.1. So I'll do half of the middle coefficient and square the result, and that's what I will add. Now back in 11.1, I would just add it to both sides of the equation, but we were working in only one variable. Now I've got two variables going, an x and a y. So what I'm going to do is I'm going to write a plus 1/4 in here. But don't forget about this 2 here. If we distributed that 2, the real value of that 2 times a fourth is really worth 1/2. So if I've added 1/2 to this side, I can also then subtract 1/2 from that side. That way I've added something that's worth 0. You can always multiply by 1. You can always add 0. So here we have a plus 1/2. Here we have a minus 1/2. I've added 0 to the right-hand side. So I'm going to hang on to that 2. Then we factor what's in the parentheses. So this will be x plus 1/2 quantity squared. Remember our little shortcut, what's in the parentheses here is your second term there. If you're not convinced that this and this are equal to each other, off to the side or on a scratch paper, multiply it out. Write 2 copies of this, FOIL it out, and convince yourself that this is true. Plus 5 minus 1/2 is plus 4.5. So now this problem looks like it did in section 11.5. So the things they want, the vertex. The vertex comes from all of the shifting. We have a plus 1/2 inside. Remember, inside with the x works backwards. Plus takes you left, minus takes you right. So our 0, 0 would shift to the left by 1/2 of a unit. Plus 4.5, we would shift up 4.5 units. I'm going to jump around the order a little bit in here, since, as I mentioned before, the vertex and the axis of symmetry are closely related. The vertex, notice, highest or lowest point, axis of symmetry goes right through the vertex. And since this is a function, the line of symmetry is always going to be a vertical line for a function. So it will just be a vertical line is an x equals. So x equals -1/2 is our axis of symmetry, also called line of symmetry, whichever version you prefer to call it. You do need both sides of the equation, though. You can't just say -1/2. That's x equals -1/2. Otherwise, I don't know. Do you mean x equals -1/2, y equals -1/2, what equals -1/2? The direction that it opens, whatever sign A has, that's the direction. Positive is up, negative is down. This one is positive, so this opens up. And that pen's dead. Okay. So this opens up since A was greater than 0, positive. Intercepts. Now before I draw a more detailed version of this graph, I'm first going to save myself a little bit of work, possibly, by figuring out the vertex and the direction. This vertex, -1/2, positive 4.5, we're in quadrant 2. We're opening up. So without even having a scale on anything, I can tell that we will have one y-intercept, and for any quadratic function you will have one y-intercept. Not necessarily true if it's just a quadratic equation, but does have, if it's a quadratic function, we have one y-intercept. And notice here, if we're opening up, we're never going to touch the x-axis. So we'll talk about a couple different ways that we can see that we have no x-intercepts. So we'll do the short one first, the y-intercept. Y-intercepts, remember, only happen if x is 0. We can go with either version. The y-intercept is easier with the original version. So f of 0 is Square root of 2 by 0 squared plus 2 by 0 plus 5. F of 0 equals 5. So our y-intercept, the ordered pair, would be 0, comma 5. X-intercept or intercepts, we know from our sketch we shouldn't see any. Let's say you didn't do your sketch to start with. How would we know? Well, if we go to the second version is easier on the x-intercepts. X-intercepts, automatically we know y equals 0. So 0 is 2 by x plus a half quantity squared plus 4.5. We'd subtract 4.5 on both sides, then divide both sides by 2. So negative 4.5 is negative 9 halves. Half of negative 9 halves is negative 9 fourths. So negative 9 fourths is x plus a half quantity squared. What I would do from here, perfect square equals constant, square root of both sides, plus or minus on the side with the constant. And here's what tells me, proves to me we have no x-intercepts. Yes, there are some complex numbers outside of the reals that would get this job done. But as far as an x-intercept, remember the x-axis is just a real number line, so is the y-axis. So we've been kicked out of the real numbers. We're not on here anymore. So we have no x-intercepts. Now as far as sketching the graph, that one I'll do on the next page. So a reminder of where we left off on this. So we had a y equals 2 by x plus a half quantity squared plus 4.5. So again, we'll go just 10 in each direction. Doing that on the 1/4 inch is the fastest way to go. Here we go. And 1/4 inch down this way as well. And then we'll just turn it 90 degrees and do the same thing for our horizontal axis. So all of that information that we gathered can be used to help us sketch the graph. So here's our x-axis, our y-axis. So we knew our vertex ended up at negative 1/2, positive 4.5. Right about there. We know we're opening up. We know that at 0, 5 we have an intercept. We know that our line of symmetry is x equals negative 1/2. So we have a nice dotted line going right through that vertex. So that also means a half a unit the other way. We would have a mirror image of that point. And then we can think about our stretching. So the original was y equals x squared. We would go 1 unit out, 1 unit up, since 1 squared is 1. But here a is 2. So we're stretching by a factor of 2. So if you think of switching, we'll do just a short little what if one, y equals x squared versus y equals 2x squared. 1 squared is 1. 1 times 2 is 2. So I'm going to go 1 unit away from this so that x equals positive 1/2. And then up, instead of 1 unit, 2 units. So there is up 1, there is up 2 units. And again, we have its partner across the way. 2 units out, 2 squared is 4, 4 times 2 is 8, so 2 units out and 8 units up from the vertex. So here's 2, 3, 4, 5, 6, 7, and 8, right about there, and right about, a little bit higher, there we are. So steep graph, should make sense, it was vertically stretched. We have our axis of symmetry, we have our y-intercept, we had no x-intercepts to graph. So that gives us a pretty good picture of what's happening. All right, so do one more like this. So do g of x is x squared plus 8x plus 11. It's the same thing, vertex intercepts, axis of symmetry, etc. So we'll make the switch over temporarily to a y equals notation. We'll sort of move our constant over. Here, this time, we already have a leading coefficient of a nice, neat, pretty 1. So I'll do half of 8 and square the result. So that is 4 squared, or 16. So I'll put a plus 16 here, which means also a minus 16. That way we add to 0. So y is x plus 4 quantity squared. So that's factoring this much. Putting those two terms together, we have a minus 5. So our vertex shifted left 4 units and down 5 units. Our axis of symmetry is x equals, and just grab whatever x coordinate your vertex had. A is greater than 0, so this opens up. So our vertex is now in quadrant 3, and we're opening up. We're going to have a pair of x-intercepts and a y-intercept as well. This doesn't give me a very good idea of the exact scale of where they are, just a rough idea just based on quadrant and direction it's opening. And that's enough to get a pretty good idea. So our y-intercept, remember that only happens when x is 0, and that's easier in the other form, the original. So g of 0, 0 squared plus 8 by 0 plus 11. So g of 0 is 11. So 0, 11 is our y-intercept. X-intercepts, I know I have 2 of those. Those are easier to find on the second version. We know that y is equal to 0 if it's an x-intercept. So 0 is x plus 4 quantity squared minus 5. And since we've already done the heavy lifting on completing the square, we can just use the square root method to finish it off there. That will save you a lot of time, a lot of work if you just use the square root method on this. So plus or minus root 5 is x plus 4, and just subtract 4 on both sides. So x is negative 4 plus or minus root 5, and throw those two into ordered pairs. All right, so from there, you would sketch the graph. Here I had an a equals 1. We had no stretching to worry about. All right, so let's keep all that stuff in mind, and we'll flip over to our next page. Let's sketch this. And here we'll just use the magic of editing to get our grid going. Okay, so poof. We have our grid, and I just copied the pertinent information over for our graph. So our vertex is at -4, +5. 2, 3, 4, and up. 1, 2, 3, 4, and 5. So there's our vertex, our line of symmetry, x equals -4. 0, 11 is our y-intercept. Which also means we have an equivalent point. And that is 4 units the other way. -4, my apologies, this should be -4, -4, -5. Let me copy it correctly. Okay, that's why that wasn't making sense to me. So -4, -1, 2, 3, 4, and 5. So here is the corrected one. So 4 units the other way from this guy, we also have a point. So at -8, so -5, 6, 7, 8. We also have a point up here at the +11. Okay, no stretching here. A was worth 1, leading coefficient of 1. So 1 unit away, 1 squared is 1. I'll just go 1 unit out, 1 unit up. 2 units out, 2 squared is 4, 1 unit away, and 4 units up. 3 units away, 3 squared is 9, 9 units up. So 4, 5, 6, 7, 8, and 9. And its partner over here. So notice we didn't land precisely on nice, neat, pretty integers for our x-intercepts. That's okay, that does happen. Square root of 5 is bigger than square root of 4, so it's bigger than 2, smaller than square root of 9, smaller than 3. So if we have -4 minus 2 point something is -6 point something. -1, 2, 3, 4, 5, 6 point something. And -4 plus 2 point something, -1 point something. So it does fit with the graph. All right. Let's see, so our next one, I'll have you all try one out. So you're going to do f of x is x squared minus 4x minus 5. By completing the square, you're going to find the vertex, the line of symmetry, also called axis of symmetry, y-intercept, any possible x-intercepts if there are any. All right, so give that a pause and we'll finish it together. Okay, welcome back. So starters, we're just going to move over the -5. Leading coefficient's already a nice, neat, pretty 1, so I will do half of -4 and square the result. -2 quantity squared is +4, so I'll put a +4 here, which means I will also have to subtract 4. That way I've added 0 to the right side of the equation. So y is x minus 2 quantity squared, so that's this much of it. And over here we have a -9. So as far as our vertex, that is at 2, -9. So remember, opposite direction of what you expect inside the parentheses there. That makes our axis of symmetry x equals 2. Our y-intercept, that happens only when x is 0, so we find f of 0, so we go with the original for the y-intercept. So 0 squared minus 4 times 0 minus 5. F of 0 is negative 5. 0, negative 5 is our y-intercept. And our quadrants. We can use our quadrants to figure out if we have x-intercepts. So we're at positive for the x, negative for the y. We're in quadrant 4. So we're somewhere in Q4. Our direction, A is positive, so we open up. That means there are x-intercepts. If we were in Q4 and opening down, no x-intercepts then. So that was for finding our y-intercept, our x-intercepts. Replace y with 0. 0 is x minus 2, quantity squared minus 9. Add 9 to both sides. So 9 is x minus 2, quantity squared. Square root of both sides, plus or minus on the side with the constant when you introduce a square root to an equation that didn't have it. So plus or minus 3 is x minus 2. Add 2 to both sides. So x is 2 plus or minus 3. So 2 plus 3 is 5. So we have 5, 0. 2 minus 3 is negative 1, so negative 1, 0 as well. Okay, so from there, I'm going to again use our fancy little editing capabilities on this and get our grid gun. Okay, poof, there it appears. So there is our lovely little grid. So we just put up all that information we gathered. So a vertex at 2, negative 9. Line of symmetry at x equals 2. So dotted line, not solid line, just because only this point is actually part of our graph. The rest are guiding us on how to find other points on our graph. Let's see, A is worth 1, so 1 unit out. We go only 1 unit up. 2 units out. 2 squared is 4. 4 units up. 1, 2, 3, 4 units up. And notice that fits nicely with our y-intercept of 0, negative 5. 1, 2, 3, 4, and 5 units down. So 2 units the other direction. We have another freebie there. And 3 units away. 3 squared is 9. And there's our positive 5, 0. And 3 units the other way. And there's our negative 1, 0. So all that information that we gathered does fit with our nice pretty picture there. Okay. All right, so that is it for the opening up examples. So I'm going to give you the full assignment, and I'll ask you to skip anything that has an A that is negative. We will do part 2 next time. So skip anything where we have f of x equals negative something x squared. All right, so our problems to try out from this one. So this is section 11.6. 1 to 10 all. 11 to 22 all. And 23 to 53 every other odd. And again, if A is negative, for the moment, skip that. We'll hit that on the next video. Stay safe out there. Thank you. Email me with any questions.